3D trigonometry. In today's lesson, we will be looking at answering questions regarding 3D trigonometry. Okay, so let's have a look at some example questions. The first question here is A, B, C, D, E, F, G, H is a cuboid as shown. First part of the question says calculate the length BD, and the second part of the question says calculate the angle between BH and the base of the cuboid. Okay, so the first part of the question says calculate the length of BD. So we can draw that in. Okay, I'm just going to draw that. Let's get a ruler. See if we can do it with that. Okay, there we are. Okay, I've drawn my line BD. Okay, so it's important to understand or identify where you can see a right angle triangle. Now, if I just draw this bottom, the base out, the base is the rectangle, isn't it? It's 7 by 4. So let's draw that out here. Okay, and we're going to say that there is 7 centimeters and that there is 4 centimeters. That's B, that's C, that's D, and that's A. Yes. Well, we know that this is a rectangle, so that means that these corners here are all 90 degrees, aren't they? We want to work out B to D. So if I just draw my dotted line of B to D, we can see here that this here is a right angle. Yeah. So what I'm going to do is I am going to draw that out. Okay. Oops. I'm trying to leave it there. That there's a right angle. I know that there is 7 centimeters. I know that this there is 4 centimeters because the opposite sides of a rectangle are the same. And I want to know this side here. Now we can use Pythagoras on this because we've got a right angle triangle and we want to work out the hypotenuse, which is C. Doesn't matter which way around A and B is. So I've got C squared equals A squared plus B squared. C squared is what we want, so leave that as it is. Then 4 squared plus 7 squared. C squared equals, well, 4 squared is 16 plus 49. Yeah. And then C squared, well, I need to add that up. I need to add 16, add 49 up to get 65. Okay. And then obviously I want to just work out what C is. And I'm going to do the square root of 65, which is on a calculator, 8.0622577748. And if I just round that to 2 decimal places, and I'm left with 8.06 centimeters. That's the first part of the question. Okay. Right, so the next thing says calculate the angle between BH and the base of the cuboid. So where's BH first? So you've got to identify BH. So get a different color pen. Well, B to H is this one here. Okay. And the base. Okay, the base is the bottom, isn't it? Base is the bottom, so it's this angle. And you can see that you will be needing the line BD in this question. So they've helped you out here by asking you to work out BD. Now, important part to know is that, and that there, this becomes a right angle triangle, okay? So again, if I draw my triangle here, I've got my right angle triangle. Okay, let's draw a bit of that. Let's try again. Okay, right. I've got my right angle there. I know this height there, that's 6 centimeters because that's 6 centimeters. So all these are going to be 6 centimeters, aren't they? So I've got that as 6 centimeters. I want to know this angle here, and I'm going to label that as theta because I don't actually know what the angle is. Well, I know the base is this. And we've worked that out, which is 8.06 centimeters, but I don't want any rounding issues. So I'm going to leave it as the square root of 65, okay? Because the square root of 65 is actually 8.0622577748. It's not 8.06, is it? That's just rounded up. So because I want to avoid any rounding issues, I'm going to use the square root of 65 as my answer. Okay. So now, I'm not going to use Pythagoras because I'm not working out a side. I'm working out an angle. Therefore, it's going to be trigonometry this time. So label your triangle. I've got the opposite and I've got the hypotenuse given to me and I want the angle. So again, up to you. You can draw your little triangles out. So, Ka, Toa. O and H is this one here. Okay, so I'm going to be using sine. So sine theta equals, well, to work out sine is opposite over hypotenuse. Opposite is 6 over the square root of 65. Well, I want to undo the sine, so I need to do sine minus 1. Okay, and then if I do that on my calculator, 6 divided by the square root of 65, and then inverse sine it. Oh, and I end up with, to make sure that my right format as well, my calculator. Okay, and I end up with 48.09115212, and I'm going to one decimal place. I'll write that for the examiners. There, yeah, 48.1 degrees. Okay, lovely. Right, okay, let's have a look at another example then. Yeah, shall we look at another example? Okay. Moving on to another question here. Let me have a look at some of the different ones. The diagram below shows a rectangular box with top A, B, C, D and base E, F, G, H. The distances are as indicated in the diagram. From the diagram, find the distance BH and the angle FHB. So again, very similar to the first example. And then what we'll do is we'll move on to something a bit different. Okay, so we are working at BH. Where's BH? Okay, so BH this time, if I get my ruler and I'll try and join that up. Okay, if I can, that's BH. Well, to work out BH, I've got to need this side here first, because then I can also use this side here, because that will become a right angle to work out BH. So to work out this dotted side here, I'm going to use number 1, I'm going to use Pythagoras, because that triangle there, that there is 5 centimeters, that there is 12 centimeters. Yep, 12 by 5, and I want the diagonal. So again, I'm going to use Pythagoras. That's C, that's A, that's B. It doesn't matter which way A and B is. So C squared equals A squared plus B squared. C squared equals 12 squared plus 5 squared. C squared equals 145 plus 25. C squared equals, well, 144 plus 25 is 169. Then I've got to square root that, and I get C is 13 centimeters exactly. Okay, so I've got 13 centimeters here. I can then work out BH. Because if I draw, let's write number 2 out. Let's use a different color. I have got, if I draw my triangle out, yep, I know that side there is 3 centimeters. That there is 13 centimeters, and I want this side here. Again, I can use Pythagoras. So C, A, and B. Now you might be thinking this topic is 3D trigonometry. So why are we using Pythagoras? Well, you need to use Pythagoras in 3D trigonometry. It's when you're working out the angle, you use trigonometry, but you need Pythagoras to work out certain lengths before you can actually go on to work out trigonometry, use trigonometry. So I want that side there because that's 3, that's 13, and I want the diagonal. So I've got C squared equals 13 squared plus 3 squared. C squared equals 169 plus 9. Okay, well, 169 plus 9 is 178. And if I square root, I get the square root of 178, which is 13.34166,406. So 13.34 centimeters rounded to 2 decimal places. Okay. So now we've worked out the side that they've asked for, yeah, which is that there. I've rounded to 2 decimal places. The second part says the angle FHB. Okay, so it's going to be this, isn't it? Start from FHB. So it's this one here. This is the angle that I want. So I'm just going to draw that here. I know, oops, get rid of that. I know that's 3 centimeters. I know that's 13 centimeters. And I want this angle here. I also know this diagonal side here, which is the square root of 178. I could use that as well if I want to, but I'm just going to stick with 13 and 3 because they're whole numbers and it's going to be easier to work with. So I want to call that theta because I don't know what it is. That's the opposite. That's the adjacent to the angle. So again, you can draw your little triangles out. Okay. Okay, that's so ka toa. Which one uses O and A? It's this one here. So we're going to say tan theta equals opposite over adjacent, which is 13. Because I want to work out the angle, I'm going to have to do inverse tan. Okay, so I'm going to do inverse tan of 3 over 13. And I end up with 12.99 461,679. Okay. And so therefore, my answer, I'm just going to round it, okay, to 1 decimal place is 13, oops, not 13 centimeters, 13 degrees to 1 decimal place. Okay. Nice and simple and straightforward. Okay. Let's have a look at another example then, shall we? Okay, let's have a look at this question here. So zoom in a little bit. So we've got this question here. It says a vertical flagpole TP stands in the corner of a horizontal field QRST. Using the information given in the diagram, calculate A, the height of the flagpole, or B, the angle of elevation of P from S. Okay, so first part of the question, we want to calculate the height of the flagpole. Okay, so that's this bit here, isn't it? That's what I want to work out. That's the height that we want. Yeah. So let's get rid of that so we can clearly see it. Right. Okay. So there's different ways that you might want to look at this. But I'm going to say this. It looks a little bit different. It doesn't look like it's a right angle triangle, but this actually is. Yeah. Because look. Yeah. That's a rectangle. There you are. And that's going to be the hypotenuse. That's your right angle over there. So I'm going to say that this side here is 30 meters because this there is 30 meters and you've got a rectangle. Yeah, it's a field. Then I know this angle there is 34 degrees and I want to know the height here, which is going to be X centimeters. So that's my opposite and I've got my adjacent. So if I look back at my triangles, so So O and A is tan. So I'm going to use tan 34 because that's my angle equals X over 30. And I want to know what X is. So I'm going to times both sides by 30. 30 times tan 34 equals X. So 30 times tan 34. And I end up with 20.2352551 centimeters. Okay, and obviously I can round that, so 20.2 centimeters, and that's to 1 decimal place. Okay, then I need to work out the angle of elevation of P from S. So P from S, oh, this spot here, so there's P from S. Okay, so we know the height of my flagpole. So if I just quickly draw my right angle triangle out. because that there is going to be a right angle. Yeah, I know this side there is 15 meters. I want this angle there because I want P from S going to P. Yeah, which is that bit there. I know that bit there is, I'm going to write down the full number because I don't want a rounding issue. 20.2352551. And I want that angle. So I've got the opposite and I've got the adjacent. That again, if you look at our triangles, opposite and adjacent is tan. So I'm going to do here, tan theta, which is the angle, is opposite, which is 20.2352551 over 15. And I've got to do inverse tan of 20.2352551 over 15. Okay, and I end up with 53.45118137. I'm going to round it to one decimal place. 53.5 degrees is my answer. Okay, lovely. Right, let's have a look at one last question then to do with 3D trigonometry. This one here. So a vertical flagpole, OP, stands in the center of a horizontal field, QRST. Using the information given in the diagram, calculate the height of the flagpole. Okay, so we want this height here. Okay, so to do that, I'm going to need to know the length of this side first. Okay, so number one, if I draw my right angle triangle out, yeah, that's this bit here that I'm going to draw out. This triangle is rectangle at the bottom, that's right angle. That there is 10 meters. On the bottom there is 24 meters. So I want to work at C, that's A, that's B. Okay, so let's use Pythagoras for that. C squared equals A squared plus B squared. C squared equals 24 squared plus 10 squared. C squared equals, well, 24 squared is 576 plus 100. Okay, C squared equals 676. I've got to square root that now. Okay, square root my answer. And I end up with 26 meters exactly. Okay, so that there is 26 meters. Now, if you have a look at that, it says a vertical flagpole OP stands in the center of a horizontal field. It's in the center. That's in the center. Well, if this whole line here is 26 meters, I will know half of this line here. That will be 13 meters. So I'm going to draw myself my triangle. That there is 13 meters. That's the center. So it's going to be right angle there. And that there is 42 degrees. And I want to calculate the height. That's going to be my opposite. And I've got my adjacent. Again, using SOHCAHTOA, you will see that it's tan that has the opposite and the adjacent. Yeah, so let's draw that out to double check. So SOHCAHTOA is tan with the opposite and adjacent. So tan 42 equals opposite over 13. I want the opposite, so I'm going to times by 13. 13 times tan 42 equals opposite. I'm going to tap that into my calculator. Okay, and I'm left with 11.705, 2, 5, and 8. Okay, 5, 2, oh, missed something out. Let's start that again. 5, 2, 5, 2, 5, 8. Okay, it's meters, not centimeters. If I round that to one decimal place, 11.7 to 1 dp, so the examiner knows that I rounded to 1 dp. So these were some example questions to do with 3D trigonometry. The questions were taken off Whiteboard Maths, and the first question was taken off TES from another member of staff who creates resources on there. So these questions were taken off various places to show you as examples. So that was 3D trigonometry. The most common question is the questions that we did at the start, which are these cuboid questions. They come up in the exam quite a lot, where you have to use Pythagoras and then trigonometry at the end. And the last two questions I showed you were slightly different questions, were not cuboid questions. So again, that was still counted as a 3D trigonometry question. I hope this lesson was useful for you. Thank you for watching.